Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in today's video is application of properties of various types of quadrilateral in problems. This is the continuation of the previous video. In previous video we discussed various types of quadrilaterals and their properties. Now let us take few examples and apply them. Here is your first example. Please read the question. Find the value of each of the pronumerals in the kite shown here. Give reasons for your answer. Please look at the figure. Okay, we know that one pair of opposite angles are equal for this kite shape. This figure looks like a kite and we know the property one pair of opposite angles are equal. So I am going to use this property for the given angle. Subtract 4 from both these sides. Divide both these sides by 3. So you'll get the x value. We are just asked to find the x value. In case if you are asked to find the opposite angle, you can plug in back the x value and find what is that. Or you can straight away say that it will be equal to 112. Please read the question and read the directions carefully. Now we are supposed to find the y and z. We know that this pair of the kite would be equal. I have marked it as this. So z would be equal to 3. Same way the other two pair, this pair would also be equal. So y would be obviously equal to 7. We need no calculation. We can just equate it. In case if you have any expression here, you need to do the same way we did for this one. You need to do the algebraic steps. Hope you are clear with this example. Here is a trapezium. Okay, we have two of the angles given and two angles are unknown. And please look at this figure and find what are the two allied angles. X and 130 are two allied angles and y and 140 are allied angles. If you add these two angles, I mean the allied angles, you will be getting 180 degrees. That is the property. So x plus 130 will be equal to 180 and y plus 140 will be equal to 180. Subtracting 130 from both these sides, you will be getting x is equal to 50 degrees. Subtracting 140 from both these sides, y value would be 40 degrees. This example didn't mention this is a regular trapezium. In case if you get a regular trapezium, there will be a congruent sign on these two sides because the side that is not parallel will be equal for a trapezium. Hope you remember the list of properties I have mentioned in previous video. In case if you get this sign, then you can say that these two sides are congruent and the trapezium is a regular one. In case if they are not mentioned, you can consider that as a irregular trapezium. So the property, the base angles are equal, will not work out here. Let me show one more example where you can see the base angles are equal, and for that the figure would be a regular one. Okay, let me explain you the difference. Please note that there is no congruency symbol in this figure. Here is an example for a regular trapezium. Please note the symbols given on the figure. It says that these two sides are parallel and these two sides are congruent. Now let's apply the property of a regular trapezium. For a regular trapezium, base angles are equal. The two angles given in this example is 4x and 2x plus 28. There are only one variable is used, so it is easier for you to solve it. You can just equate them and solve for the unknown variable. Subtract 2x from both these sides. Divide both these sides by 2. Hope you are clear with this trapezium problem. Okay, let me take one problem with parallelogram. From the previous two examples, you would have learned the difference between a normal trapezium and a regular trapezium. Okay, here is the next example. Okay, we have a parallelogram. You can use two properties here. One is opposite angles of a parallelograms are equal. You can equate these two and solve for x and y. Or you can take another property. If you add these two allied angles, you will be getting 180 degrees. Okay, let me take both the properties and show how to find. First, let me use opposite angles of a parallelogram property. Subtract 40 from both these sides and divide both these sides by 2. On dividing by 2, we get x is equal to 15. By the same property, you can find y by equating 5y plus 15 equal to 110. Okay, but I'm going to use the other property. If you add these two, you should get 180 degree. This is one angle, add 70 to that. By adding, you should get 180. Now let's apply the algebraic concept. Add 15 and 70, that would be 95. 85. Subtracting both these sides by 85 will get, divide both these sides by 5. Therefore, the two unknown variables are 15 and 19. Hope you are clear with this example. We were discussing the properties of sides and angles. Let me take one example where we will be applying the properties of diagonals. In this question, it is mentioned that PQRS is a parallelogram and we don't have any values for the sides. We just have the information for the diagonals. So you can use the diagonal property. I hope you remember the property. We know that the diagonals bisect each other. So therefore, you can say that SO will be equal to OQ. Same way, this half PO will be equal to OR. Replace SO by 16 and OQ by x plus y. Just swap the sides. Let this be our equation number 1. Now I am going to take the next equation from the other diagonal. We are going to apply the same property, diagonals bisect each other. You can say that the piece PO will be equal to OR. By plugging in the given values, we will be getting 20 equal to y plus 7. Subtract 7 from both the sides, we get. Just swap the sides. We have got the value for y. Let this be equation number 2. Substitute equation number 2 in equation number 1. That is, I am going to replace y by 13 and solve for x. Subtract both the sides by 13. Hence x and y values. Hope you are clear with this example. I'd like to show you an example with a rhombus. Again a diagonal property. Here is the next example. We have a rhombus. Please note that in case if you have no names for the vertices, it is better you name that, because to avoid the confusion and miscommunication, you better name the vertices and the point meeting. So the midpoint be M. For a rhombus, all the sides are equal. So all the 4 sides would be equal to 17. And next property is the diagonals. The point at which the diagonals meet would be 90 degrees because they are perpendicular to each other. Therefore, the angle AMD would be equal to 90 degree as the diagonals of the rhombus intersect at right angles. So what do we generally apply when we get a right triangle and 2 of the sides are given to find the third side? When a right triangle is given and you know 2 of the sides, and if you want to find the third side, we generally apply Pythagoras Theorem. Am I right? So we are going to do the same thing here. Let's apply Pythagoras Theorem for the triangle AMD. Pythagoras Theorem is nothing but the longest side of the triangle square equal to sum of the squares of the other 2 sides. So what is the longest side for this triangle? AD is the longest side and DM is the shortest one and MA is the second shortest. You have to take the squares of these 2 sides and add them. That will be equal to the square of 17. This is called Pythagoras Theorem. Now let us solve for x square and let us simplify it to x. X square is 225. To find the x value, I am going to take square root on both the sides of the equation. Please remember, whatever operation you are doing on one side of the equation, you have to do the same thing on the other side of the equation too. Only then the equations will be balanced, or you may end up with the wrong answer. If you take the square root of a positive number, you will have to place plus or minus sign before the answer. But we are dealing with the sides. The length or the measurement cannot be a negative number. So I'm not going to consider the negative 15. I'm just taking the positive 15 as our answer. Here is the next example. Okay, side of a square is 17 over 15 centimeter as shown. This is a fraction. We are supposed to find the length of the diagonal now. Please note that the diagonal xy divides the square into the square pxry into 2 right angle triangle. We know that the angles are already right angle. The 4 angles of a square would be right angled. And if you divide this into 2 equal halves, it will look like 2 right angle triangles have been pasted. XPY and XRY. So in the right angle triangle XPY, you can apply the Pythagoras theorem as we did in the previous example. Now let's apply the Pythagoras theorem. We know that Pythagoras theorem says the longest side square will be equal to squares of the other 2 sides. So the longest side for this triangle is XY. Shortest and other 2 sides are, you cannot define this as shortest and second shortest because all the sides are equal for a square. You can take it as an isosceles triangle. So these 2 sides will be equal. Now plug in the sides. All these sides are equal. So 17 over 15 for both. 2 times 17 over 15 the whole square. 289 over Or you can keep this as squares. In case if you take a square root, you can give your answer as 17 over 15 times square root 2. In case if your the options given in your question is given in decimals, you can convert everything into a decimal. I'll give you both the answers. Taking square root on both the sides, or you can take square root in this step itself. If you do so, you'll be getting both are same. That's it for this example. So when you're given these types of problems, look at the geometric figure carefully. Once you identified what shape it is, then you can look for the given information. If the given information is talking about the sides, then you have to look for the properties that deals with the sides. In case if you're dealing with angles, most probably you'll have to deal with the corners and the diagonals, because only when these two intersect you'll be getting some angles. Same way, when you're dealing with trapezium problems, you have to check whether they are regular or just the information is given. In case if they are regular, the concurrency symbol will be given on left and right side. I'd like to give you some quick tips on the properties of quadrilateral application in problems. A quadrilateral whose opposite sides are equal and parallel. A quadrilateral means itself you should know that the opposite sides are equal and parallel. And opposite sides angles are equal. And the most important property you must know is sum of any adjacent angle is 180 degrees, that is supplementary. Diagonals bisect each other, and diagonals need not be perpendicular or equal. Each diagonal divides a parallelogram into two equal triangles with the same area, triangle of equal area. Same way, area of a parallelogram is double the area of a triangle formed by the diagonals. Hope you understand this point. Bisector of the angle of the parallelogram form the rectangle. Okay, so these are the things you have to keep in mind while you are solving the problems based on properties of quadrilaterals. Hope you are clear with this session. See you in the next video. In next video we can see the problems based on trigonometry.